I love it. I love it. The countdown is here. I get excited as well. I know that the folks that are in the studio with me get hyped with the countdown. So I appreciate that y'all appreciate it. Once again, my name is Rosendo. I am from MLH. I am here for Global Hack Week September, as are you. That's why you're watching. We're also here to learn a little bit more about DigitalOcean cloud functions today. And we've got just the person to come along and teach us about it, Amy Negrete, developer advocate from DigitalOcean. And we're going to see what cloud functions are all about. I mean, cloud functions, who knows, right? We're here to learn, and I think it's going to be extremely interesting. So without any further ado, actually, before I get into that, make sure you drop into the comment section, add your questions, let us know what's going on your end. We're going to be doing some technical content today, so be sure to let us know what's going on with your stuff in the comment section. And like I said, without any further ado, let's go ahead and bring in Amy. Hi, Amy.
Hello. Good morning or afternoon or evening, depending on where you're coming from, I guess.
I'll leave y'all to it.
Right. So we're going to talk about serverless functions, which I know if you're going to get into cloud, you're going to hear a lot about, and it's not going to make a lot of sense because the word is used pretty poorly in our industry. So we're going to walk through it and make sure that everyone will get a nice firm foundation on what all of these buzzwords actually mean and how you can use it to kind of help your learning and development. So thank you. We're going to get started with functions. Can I ask the chat real quick, what your familiarity is with either cloud services or functions or even containers and serverless? I would be interested in knowing so that If you can help out in your various chat rooms, that would be great. And I strongly encourage questions because, again, it will sound a little confusing, especially if you are very new. One of my favorite hearsay is a really good way to kind of go into what a lot of people expect from this type of architecture. But don't worry, we're going to, like I said, from foundation, we're going to go in and explain every word that I intend to use. Don't worry about it. But that's good to know. That means I set these slides up real well. So let's get started. Um, I did put a prerequisite list here is obviously sign up for Global Hack Week if you haven't already. If you already have a DigitalOcean account, it'll be great because this is going to be a code along in the back half of this. So you can either follow along, you can watch this. I will also show you a link so that you can also go back to these exercises at any time during Global Hack Week and participate in your own time. And you can ask questions whenever you'd like. So let's kind of break down what a typical web app looks like. Uh, Typical web app, you have a server and you pull that data from a database. Either database, sometimes you pull from storage, and then you set it and send it out into the wild, and it will come up on someone else's screen, or maybe it's not even a screen, maybe it's an API endpoint, so that you're just passing data back and forth. That is how I learned how to do this, and that was quite a long time ago. So I want to show you how similar it is instead of how different. So a serverless app is essentially the same thing, except you're using a provider's managed services. You have a cloud compute that you don't have to provision a server for. You are using a managed database that the configuration is handled by the provider. And there are also pure serverless databases where you connect purely through APIs and SDKs. You don't, which is a very technical way of just saying you're using commands to access it instead of accessing the actual raw data. So you can use that to essentially fulfill the same purpose. If, as far as examples go, Gatsby, Jekyll, those sorts of static site services, those would be considered serverless apps because you don't actually have to provision servers for them. Any Jamstack will do that. The functions will actually act as your compute if you want to do some dynamic stuff with that happens after site generation. So this is going to be our first super long definition. Again, if you have any kind of question, please drop it in chat. I will try to answer it as best as I can. So this is from a resource called the Serverless Stack. If you're interested in this kind of architecture, go check it out. They have very good tutorials on how to build a full website using serverless resources. So serverless computing is an execution model where the cloud provider is responsible for executing a piece of code. And that is what all of those extra words mean. Excuse me. It's a very detailed way of saying the provider handles things like what server is deployed, what container is used inside, and all of the optimization that goes into it. So serverless refers to any resource that you don't have to deploy provider resources for. So you don't have to set up your own databases, you don't have to set up your own storage, messaging, all of that stuff is handled by the actual provider, regardless of who it is. And they handle things like connections and networking and firewalls and stuff like that. You can, of course, afterwards make whatever changes you need to in order so that it meets whatever your standards and your needs are, but it will give you a base plate of things to connect together that you can very quickly stand up and start building on quickly. If we are using cloud, how can we call it serverless? I actually have a slide that I put in every single one of my decks. I actually didn't put it into this one where my favorite, it's called my favorite hot take, which is how can you call it serverless when it has servers? Everything has a server. If it connects to the internet and is a computer, it is a server. That's fine. It is also like, why do we call it wireless if you still have to plug it into a wall, which was a fight that I saw in an office supply store once. People still ask these questions. It is, as I said, a really bad naming term. And it does get misused a lot if you start looking through products. So the best definition is it is a resource or a component that you use that you do not have to provision architecture for. So you do not have to stand up a virtual machine. You do not have to set up your own networking. Those two things is why something is serverless. And I will actually go into this in the next slide about serverless versus containers versus cloud native and all of that stuff. But first, because this is going to be a talk on the back half specifically about functions, I'm going to explain what that is first. FAS is very specifically just the executable portion of the code. It would be like your lightweight server. Yes, we will be doing examples at the end of this talk. As I said, this is a code along, so if you're able to, you can join us. And if you don't have your account set up yet, trust me, account setup is going to be like and configuration is always the biggest hassle to do first of any project. So don't worry about it if you're not ready yet. I do realize it is early on a Monday morning. So functions are going to handle the compute portion of whatever application you write. You do have to make sure that one, they are lightweight, and two, they are stateless. There are stateful ways of building it. It is more of a personal or business decision whether or not you decide to use states within your serverless architecture. There are good reasons to do it. It does require a lot more work, but that's a little out of scope for what we're going to be doing this morning. So the way functions work is that we have a container. A container is a definition of any operating system configurations onward. So let's say you have a virtual server, and then you have your kernel, so that's like, and your operating system, that's Windows or Linux or Mac, which is Linux. And then on top of that, you have your actual application data, which is going to be your runtimes, it's going to be your libraries, it's going to be your code. A container contains the top portion of that. So that's everything on top of your kernel. So, and this is done so that it can run within reason on any other type of machine, so long as you have a proper container orchestration system or a compatible base layer. There are a lot of containers that aren't fully compatible depending if it's highly optimized for a specific type of OS, but it is still good practice to kind of have all of your application code containerized, that's why they call it that, into these little package files. So what you have is your code, which is done by, this is my screen, that's right here. So you have, that's where your code is. The way functions work is that what your provider will receive that code and build you a container for it. So it is like a container service, except you do not manage the container at all. That is purely managed by the provider. And then as that code is executed, it creates one instance, one live instance here. And then as it gets called again and again, we'll either spin up more or keep calling the same container. It really depends on the provider on how it actually works that way. And then as each execution is completed or fails or what have you, each one dies. And once all of these outside containers are expired out, then the base one will also expire out. Who is the provider? Is that DO in this instance or in a third party? This is speaking very generally. I do work for DigitalOcean. We do have functions. So in that instance, DigitalOcean would be the provider. It would also be GCP. It would also be AWS. It would also be Azure, depending on who you're using. Is there any specific reason to call them containers? Secret, like backroom industry secret. Technologists are bad at naming things. If you ask me, that's why. Okay, so serverless architecture. So on the left, we're going to is basically a virtual machine. A virtual machine is any server. They are called virtual machines in Azure, and I believe they're called nodes in GCP, and in AWS they're called AMIs and or EC2s, and in DigitalOcean they're called droplets. So the thing to remember about these is that they're an always-on machine. And because of that, they can do important things like manage state and have internal storage. And you can run software inside them, not just code, but also databases and any other kind of machine learning stuff inside, because it's essentially the same as having your own computer, but in the cloud. The thing to remember is that when you're using an always-on machine, if you are either learning or you have a product that doesn't see a lot of traffic or development on it yet, you are going to be paying for a lot of time that you are not using. So you'll have a lot of spikes, but you also have a lot of valleys where it's not great. So one of the primary points of serverless architecture is that it's pay by usage. So when a request comes through, that's when you pay for things like compute and traffic and storage. It's also by default stateless. So if you're trying to manage a session, you can't do it within that machine itself. You have to be storing it somewhere else, usually either through storage or a database. It's also ephemeral, which means when it's done with what it's doing, it goes away. If you need something where you're storing something for an extended period of time, in this case, extended can be as little as a few minutes, you need to be able to build in a process where it can hold that state somewhere else outside of the compute. And the containers for functions are very small because they are meant to be lightweight and fast. If you're doing what is called an ETL, extraction, transformation, load of data, which just means passing data from point A to point B and doing stuff to it. This is good for that because you're not dealing with a heavy amount of logic. You're not doing like graphics computation or anything like that. And you don't need to hold that state. So it's easy if you're doing data analytics or any kind of health checks or data validation. This is really good for workloads like that. if you're trying to do something that takes a really long time, like heavy state-based analytics, when I started, I was working for a fantasy football company. If you were going to do the scoring, because they had to score against the league, which meant they had to hold on to the state for several minutes, this would not work for that situation unless they stored that state elsewhere. But again, state management is a thing that if you need it, you can do it, but it is not a default architecture model for this. So I thought I had that slide in, and I guess I didn't put it in. So I'm going to do one more thing about containers real quick before we move on to our little project for today. A container, I did explain what a container did. The issue you're going to have when you start learning this, well, one of the many ones, is that as I mentioned before, there is a lot of overlap and fuzziness as far as what is considered serverless and what is considered just regular cloud-based engineering. So there is a concept called cloud native, which means everything you build specifically to be stored, and maybe not in a very specific provider, but it is meant to be cloud-based as opposed to on a single machine or in a data center. So this contains things like Kubernetes or anything that's built with a virtual machine, a network, that sort of thing. Within that, if you're just using the containers and you stop dealing with the machines itself, then you have something called container-based application design, which is dealing only with the containers and separating that from the actual infrastructure, from the cloud infrastructure. And serverless is a subset of container-based application design because it does run on a container, you just do not manage it. So it is like a little nesting egg where cloud native is on top, where you have both serverless and Kubernetes. The reason why Kubernetes is cloud native and not serverless is because it requires machines to run. And then within that is container based, and within that is serverless. So just wanted to do that real quick. And now let's see, I'm going to take a real quick pause for any questions. Okay, functions is the small serverless compute that we're going to be dealing with today. And we can't change the names of stuff, which is unfortunate. A lot of cloud uses overriding terminology, and that is something that you start learning through experience and context on why something is named the way it is and how to use it. Actually, if you are more interested in the container base and Kubernetes, cloud native is a cloud native CNCF, Cloud Native Computing Foundation. There you go. That's a great place to learn about Kubernetes and containers. And okay. Yeah, there are a lot of functions providers. And also, I pronounce it Kubernetes. That is the way I've heard it pronounced. And I will be honest, my partner calls it Kate's to infuriate me specifically. So, and if that's a list question, I'm going to move on. Now we're going to do something a little more interactive, a little more fun. Please go to this link if you can, and give me a thumbs up in chat if once enough people are in, we can move on. So what this is a functions challenge that we made for specifically for Global Hack Week. So that's why it's instead of our usual DigitalOcean background, you get nice Major League Hacking colors. And what we're going to do is test out functions, rewrite a little, and be able to push things directly to a database. And then you're going to see your own sharks show up in the fish tank. You can, if we can write functions to manipulate one or more containers in some way. You can 100% use functions to kind of adjust. I'm trying to find a way to say this accurately, but generally, you can use it to help with the orchestration of your containers. That is a thing you can do. Right now, the DigitalOcean project is fairly new, but there are libraries out there for certain Kubernetes libraries where you can actually use Lambda to manipulate Kubernetes. So that is out there. That is a growing field. So if you're interested in stuff like that, it is happening, but it is also very new to be able to do it that way. Unfortunately, you do need a DigitalOcean account. I'll be doing it on the screen here, so you can at least see it happen and see if it interests you. And once you get signed up and everything, then all of this will be available to you. So if you're having card issues, I apologize. That is not something I can manage, but if you email, I think it's digitalocean.com/support. That is the best way to get a ticket with that team and have them contact you about it. Okay. So, for now, I'm just gonna walk through this exercise. Okay. And I forgot this was a screen cap and not the actual thing. So let's go to functions challenge. MLH. There we go. So what we have here is a live fish tank where it's just a bunch of sharks just floating around doing their own thing. So if you are able to participate and you click the button, we do filter out those trying to make a request outside of DigitalOcean, just because this is specifically to teach people how to use DigitalOcean functions. The functionality will be the same. And you can follow along, but you will not be able to see your shark on screen. So there are basically two short steps, which is we're going to create a function, we're going to add our parameters, and then we're going to see it pop up in the tank. So we're going to do this. So if you're able to participate, go to the functions tab. Learning APIs and doing this challenge the challenge is going to be comparatively super easy. All APIs are a way for you to be able to access application code. So this is commonly found in the form of endpoints, so that you can also use webhooks and other things, or data streaming endpoints. But HTTP request endpoints, which is what we're going to use, that's when you look up an API document, that's often what you're going to be able to see. So all you have to do is make either some kind of HTTP request or another, depending on how they have it built. But for the sake of this argument, I'm just going to say HTTP request. So you do get, post, you can access that endpoint. You will either receive information back depending on the logic that's happening behind that endpoint, or you're going to be able to add stuff. So okay, so we're going to go into functions, and then we're going to go to create. So I'm going to use Python right now because it is the easiest way I found to do it. And also it's the way that I did it last night to make sure that the demo worked. But also it's like I've also done this challenge in PHP because I don't know Go. Our runtimes also include Node.js and Golang. So if you're into that sort of thing, yes, like those are languages you can use. Python and Node, just so you're aware, they're considered first-class languages in a lot of serverless products. So if you know those languages, you can basically use a runtime on not just DigitalOcean, but a lot of other cloud providers. I, however, am a PHP engineer by trade. So the fact that they have one in PHP is a lot easier for me personally, but we're here to teach you stuff, so we're gonna do it that way. So we're going to name our function name, or we're going to name our function. I'm sorry about that. MLH Sammy. Let's say go happy Sammy, and then under a MLH package name, and then what's going to run. So what you're seeing here is just a small bit of code. Notice no servers, no configurations. We didn't even have to set up something public with it, right? But if we wanted to, we could just copy the URL from here and go into another tab, and let's see what happens. So we get whatever runs on that endpoint. So we can actually get started right away, and we'll know exactly how to get there. And we didn't have to set up a firewall. We did not have to set up any kind of outbound networking. And anytime I can get away with doing less infrastructure work, the better it is for everybody involved. Not saying I can't do it. I'm saying I do not enjoy it. So this is our hello world structure, where you can pass it an argument like a name, and then it'll say hello to you. But for now, let me show you how parameters are going to work in this. So what parameter is it expecting? It's expecting a name. So let's set up where it goes name. Oh, you don't like me using single quotes then. Fine. That is what we call a JSON blob, which is JavaScript object orient notation. There you go. So now it says hello to me specifically. Hooray! How to go there if you're in DigitalOcean. If you go to your DigitalOcean Cloud console, it is on the left. It will be under droplets, and then you'll see the functions tab. Can you zoom in a little? I can certainly try. Let's try. You zoom in. There you go. that okay? Is that zoomed in better? So now we're going to make a little change. Well, not a little change. We're going to change everything inside. It's fine. But remember this return response, because the return response is important. Return responses generally have a required structure. This one does require a body to be returned as part of either an array or a JSON object. In Python, it's a JSON object. It is an array in PHP. So now, I'm going to show you again more super industry secrets. I'm just going to Google like Python request. There we go. You can tell I did this last night because it's already there. And then we're just going to copy this whole thing. This is how we do studying in the real world. It's a great time. So imports go on the outside. Actually, we don't need to import it. No, we do need to import. What we don't need to do is package it. So import request. And then we're going to take the URL from here. I'm going to copy that. And copy. We're going to change this to post. Then we're going to remove these. Then we're going to put that in the body because we don't need to know what the end of that is. And then times. So according to the requirements for the challenge, which is right here, we're going to set our headers, we're going to set our parameters, we're going to set the parameters first. So does anyone have a preference on the name and type of Sammy that we use? We can make it look like a pizza or a dinosaur or a robot or whatever you would like. Sharks aren't whales. Pizza. One pizza Sammy coming up. Pizza. We're going to say, calling Global Hack Week. Pay. And then we're going to save it right here. It's updated. It's updated, but I didn't actually add any parameters. So let's call it and save it again. Let's hope I remember that correctly. It's on my next slide if I forget real bad. So what we have here in our output is saying that it was created successfully. And then there's a see your shark link and this share your shark link. So if you use share your shark, what's going to happen is that it's going to give you a nice little Twitter window, and then you can share it and your friends can see what your shark looks like. So for now, let's go look here. It's there, your nice, huge Global Hack Week pizza shark. Pizza shark, pizza shark. But yeah, and that's really all you have to do. And if you manage to go through this and like solve some accounting issues, and then you go through the challenge, you'll see a lot of our challenges for the beginning of Global Hack Week are related to this specifically. So you'll kind of be ahead on getting all of your challenges done if you go through this. Hints and secrets. That's what I'm here for. So that is the simplest way you can make a function. on DigitalOcean. And honestly, I've used it on other clouds. It is the fastest way to do it. Full stop. Does anyone have any questions on what was happening or sharks? We can make another one that is also a dinosaur, probably. Let's make another one that's a dinosaur. Okay. That's slack, guys. Okay, so all we have to do. Oh, I didn't set the headers. You should also set headers. What have we? Dinosaur. Save. Updated, and then run. This is also really good if you're going to prototype stuff and you just want to make sure things like your dependencies work or your logic is actually doing the thing that you expect it to do before you drop it into your a full library or code base or application, just so that you can do just a little bit of aggressively iterative development. Let's see what this looks like. Oh, we just have to change the thing. That's right. So we're going to change this so that it says MOH equals. Where'd you go? There it is. It got bigger, but it didn't get all that much bigger. Here you go. Here's your dinosaur right here. Woo! So let's do a quick rapid review of everything we've learned. It won't be too bad. So this is the code. If anyone wants to see these slides after the talk, I will post them on Twitter and oh, you should probably know where that is. Twitter.com/NERDYPAWS. That's twitter.com/nerdypods. The slides will be there. And then there it is. If you need to see it spelled, the code is right there. If you ever want to see it, it will be in the slide and you can just read it. And that's what it looks like. So the things we went over is we went over what cloud native is, which is anything that is built specifically to run on a provider and not in a single computer or an on-premises data center, which can include container-based applications, can also include serverless, can also include Kubernetes. Then we talked about container-based applications, which is just the application code to be run in whatever orchestration service that you're running at that time, which is just the application code, and dependencies does not include the kernel, does not include the OS. And then within that, we have serverless, which is anything that does not need to not to provision a machine, and you do not manage the container itself. Okay, that is me. That is me. I can also, yes, those are both me. I will put the slides both on my LinkedIn and on my Twitter so that you have availability to it. And functions are serverless compute. Compute is the part that runs the code. It has to be lightweight. It has to be fast because these containers are very, very small. And you also pay on usage instead of just paying for a server to be up for the entire month. So there you go. Those are the most important things you need to know about serverless. If you're ever interested in learning more about it, we have a lot more content on it at DigitalOcean. It's also the thing I've been talking about basically nonstop for like 4 or 5 years now. So I'll be glad to talk to anyone about it at any time. Yeah, just either at me or DM me on Twitter, and I will be glad to either send you resources or try to answer things best I can. And that is like, I'm actually wrapped up with my stuff. Oh, thank you.
All right, folks. Rosendo here from MLH. Thank you so much, Amy. There is something wrong with my video. Obviously, for some reason, I can't see myself, but we're going to figure it out after the stream. I just wanted to jump on and say thank you so much for joining us. Content was awesome. Yes, I know my cam is off. I'm figuring it out. Now it's a yellow screen.
That's new.
Yeah. So basically, we're figuring it out after this. But I did want to say thank you so much for being here, and for all of you who have questions, feel free to drop them into Discord if you have other things that haven't been covered today. But outside of that, thanks so much, y'all, and I hope everyone here enjoys the rest of Global Hack Week. Bye, y'all.
Bye.